I'm actually really keen for this one. Rohan from Canva. He's a senior machine learning engineer. Rohan's based up here, works remote for Canva. And yeah, tonight, gonna dive into some of the work that he's been working on recommendation systems. I'm not going to talk anymore because Rohan knows a lot more about this than me. So take it away, Rohan.
Oh, too easy. Thank you. Is this just a... I don't know if stuck is the right word. Cool. Well, thanks everybody for coming. As you just found out, my name is Rohan and I'm a machine learning engineer at Canva. So I've been at Canva for about 1.5 years. And actually I joined Canva the week the pandemic happened. And that's kind of why I'm back here. I went down to Sydney to move. Everything kind of didn't pan out and I came straight back and I've been working remotely ever since. And so in that time, I've been working on the search and recommendations team, which when I joined was around 12 to 13 people. And I think we're up to about 46 right now in the space of 1.5 years. And we're kind of growing really quickly because it turns out there's a lot of stuff for us to scale in this space. And I spent the first 6 to 7 months of my time at Canva working on search, primarily search relevance. We have lots of different content, as I'll kind of talk about, and trying to make sure that when people search for things, they make sure they find the stuff they're looking for. But as our libraries and the kind of use cases for Canva have grown, recommendations have become something that have become very, very important for us because the libraries are just getting a little bit too big. And I guess on the topic of recommendations, before I move on, can I get a quick show of hands? Has anyone who here has either worked on a recommendation system or read some piece of literature, like a research paper about recommendation systems? Cool. It's actually more than I expected, so that's good. And the reason I asked that is because typically we tend to find, and this is something that I ran into, despite recommendations being the most prolific form of AI that we all interact with, whether we know it or not, and we've got some examples here: Spotify, Netflix, YouTube, Google, TikTok, etc. Everything that we use in our day-to-day lives. Recommendation systems in the context of machine learning and deep learning are typically not discussed very much. Part of that is probably because these companies like to hide a lot of their secret sauce from the average people like us. And the other part is, in general, they tend to just not be, as cool as some of the fancy new stuff around natural language processing and computer vision, I guess, the two main ones at the moment. But at Canva, recommendations are really important to us because traversing through our library of content, which consists of templates, graphics, photos, videos, audio, plus a whole bunch of other things, is really, really hard. And part of the reason why this is hard is because we have search and people are used to using search in a certain way. We all use Google. And in a content creation platform like Canva, sometimes the way you use search doesn't really translate into what you might be used to. And so an example of this might be something like looking for a dog. You go on Google, you type in dogs, you get pictures of dogs, that's fine. But in Canva, a lot of the time you'll be designing something and you look for dog and you'll get a whole bunch of dogs and they are dogs, but you'll kind of be thinking, I don't really want to put these dogs into my design because they might not look right. They might not have the right color scheme, it might just be a bad photo. And this layer and this idea of being both a content consumption platform and a content creation platform adds a whole lot of really interesting intricacy for us to work on. And it's why we're kind of spending a lot of resources getting into the recommendation space really in the last 6 months to a year. And so before we talk about kind of what we're doing at Canva and how things are kind of going in the general industry, I thought I'd give a quick just background into some literature around the typical recommendation systems, the typical recommendation models that are being used, as the state of the art. Got to show off one of Canva's cool abilities to add GIFs to your presentations. So going back about 15, probably more than 20 years, but I'm going to say 15, 20 years, we have this concept of collaborative filtering. And anyone who's probably done some sort of AI class or information retrieval class has probably heard of this. And the idea of collaborative filtering is to make recommendations by representing your user as some sort of vector of their interactions. So this diagram is from a tutorial from Google. And you can see here that you can roughly approximate a user as just a two-dimensional vector, where you put a 0 in all the items that they didn't interact with and a 1 in all the items that they did interact with. And this is your representation of that user. When you go to make recommendations for this user, all you need to do is find other people who have very similar vectors. So typically, this becomes a little bit problematic comparing these vectors because they become very, very sparse. In this case, we got 5 movies, so we can compare people's vectors easily. But if you think about something real, like the real Netflix library, where you have hundreds of thousands of movies or TV shows, comparing these vectors doesn't make a whole lot of sense because most of them are just zeros. And so what we kind of discover is we can do some sort of matrix decomposition where we try and estimate or approximate, I should say, some dense vectors that can be factorized out of our sparse vector space. And so I won't go too much into this, but the idea is that people who are familiar with lots of linear algebra stuff will know that for a matrix, we can decompose that into 2 kind of submatrices or subvectors that can, when multiplied together, form our overall matrix. And so you can use a couple of different techniques. The most common is obviously singular value decomposition to approximate these 2 vectors. And that gives us a nice dense representation of this sparse, no, that's so good, of this sparse original vector. And so this actually works really well. And this was really popular. This is what won the Netflix prize for many, many years. But unfortunately, stuff changed in the world and it started to kind of fall off in popularity. And before we do it, I accidentally deleted one of my slides. That's all right. The reason it fell off in popularity was because libraries became too big. And it turns out that while this is a good solution to solving this sparse problem, even this becomes very, very difficult when you have giant libraries of items and huge numbers of users. And that's just because decomposing this matrix in memory just becomes very slow and problematic. Additional problems that come with this are the fact that with the way you typically solve this, when you have new items or new users, this doesn't handle that in any way because your decomposition is dependent on the original state matrix that you had. So you need to do the whole thing every time you get new people in. And that isn't a great idea when you're getting hundreds of thousands or millions of new users a day. And finally, as you can see here, all we have is users and items. We have no other information included in this original matrix. And again, that was fine back then. But now we kind of want to take advantage of all the different things that we know about our users and all the different information that we know about those items. And this system is not great at doing that. You can do it just by kind of adding dimensions to this matrix, but that becomes, again, quite problematic. And so around 2013, I think the Word2Vec paper came out, which really popularized this concept, but obviously it's been around for quite a while. We have this idea of embeddings. And if we think back to this slide, what we're really doing here is creating an embedding. And an embedding is just a dense representation of some piece of data. And typically, in modern machine learning, we use these embeddings in a way that they live in a space that has semantic meaning. And so, as I said, Word2Vec is the most common, famous example of something like this. Then this is used very, very extensively throughout representation learning almost everywhere. But one way that we can kind of extrapolate this idea is to start thinking about our users and our items as spaces in this, as embeddings in this space, which is really, again, what we were doing here, but kind of translated into a more modern concept. And so as embeddings became more popular, obviously deep learning became more popular. And by 2015, all kinds of fancy state-of-the-art architectures that relied on neural networks started popping up. And this one here, this is a recommendation model from YouTube that they used circa 2015. And the idea here is to say, okay, instead of all my standard items, which I have as just some sparse vectors, let me just convert these all into some embeddings, shove them into my deep learning network, and then let the model learn the best representations to allow it to predict whatever task I'm trying to do. And so in the recommendation space, this was predict the interaction. So typically for a recommendation problem, what you're trying to do is say, I have some information. I want to know what a user is going to click on next, what a user is going to watch next, what are they going to listen to next, what are they going to buy next. And so in this kind of situation, what you're saying is I have information, and I guess for YouTube, they're saying these are the things someone's watched. Here's all the searches they've made, all the demographic information that I have. I'm going to try and do a huge softmax multi-class prediction problem and predict the videos that they're going to watch next. And this worked, right? This was a good solution to the problems that we ran into from collaborative filtering, but it also has some huge problems, mainly being that it is, as anyone who might have tried to do a large multi-class classification problem has found, hugely expensive. And this was fine for Google and YouTube because they have tons of money and tons of resources, but this didn't really scale too well. And so as the years have gone on, we've got lots and lots of new approaches come out. The most common at the moment is something that I like to call the two-tower network. And the two-tower network builds upon the idea that we had before, which is we use neural networks and we embed our inputs as dense vectors, pass them through. But we learn two separate models, one model for our items and one model for our users. And moving forward, I'm actually going to start referring to users as queries, because your user is not just your user is the user plus all the information that you know about them. And so the idea here is, instead of doing a softmax classification problem, we try and project these user and query embeddings into a space and then use a dot product loss to minimize their distance. So in this context, the user would be their state and the item would be something that they interacted with as per their state. And the idea is you're training a model to minimize the space of these embeddings so that they are close to each other, because users that are close to items will be similar and items that are close to other items will also be similar. And this obviously translates into being able to use the space to easily make recommendations. And yeah, I've got a couple of notes here around this being extremely flexible. As you can see here, if we model two different towers, we can do whatever we want in each of these. I could stick an LSTM into my user tower to absorb a long history of what someone's been doing, process the history, add that in. I could add a transformer to ingest the last image that they exported and include that as part of my tower. It's really, really powerful.
So does that mean in this case, you basically just need to look up or calculate like the coastline distance between the user and nearest item?
Yes, so that's what happens at serving time. And that's why I've got, it translates well to a serving environment. I have a diagram actually a bit later that shows exactly what that looks like. But yes, that is why it's good. Cool. And so I won't talk any more about this, but from this, I mean, obviously that paper came out, I think, 2018. Tons and tons of other stuff has come out because this area has exploded, and it turns out there are lots and lots of different ways to make recommendations. We've got multimodal recommenders, which is what I described, using lots of different other models that take into account audio, video, text. We have graph-based recommendations, which are starting to become really popular with really large libraries, because graphs are a good way to handle corpora when you get into the billions and 10 billion size of data sets. And so with all this in mind, you kind of notice I'm rushing over this a little bit, and that's because the reality is we hear about recommendation systems. No one ever writes a paper about a recommendation. Well, they do, they write papers about recommendation models, but in the industry, and typically you'll hear about recommendation systems. And that is because it turns out in most use cases, the ability to just predict what someone's going to do next or click next from a raw score is not actually super useful or super feasible. And so this next part here, I'm going to talk a little bit around what I mean by system. And so this is kind of what a modern recommendation system looks like. And you'll notice that you have quite a few different parts here. Typically, the way it works is we have, normally you would have probably what would be 4 stages, but I'll condense them into 3. We have some sort of query about something we're trying to make recommendations about. We have a step called candidate retrieval, which is about generating an initial set of recommendations from a lot of data. We then have a step called scoring, which is about taking this set and refining it down using really precise features. And finally, we have a step called re-ranking, which is probably the one that no one really would have heard too much about, because it's a bit of a hack. It kind of makes what you've done in the previous steps seem a little bit like you've cheated. And so you'll notice in here, we actually have two separate models as part of this system. And a lot of the time you'll actually have a separate model that you can use also for re-ranking. And we'll talk about that. And the idea here is that we have a query. We generate candidates from a giant corpus. We then take those candidates and we score them using features from a feature store, because you don't want to pull from your feature store for all, 1 million, 10 million, 100 million items. That's just not practical in a production environment. And then we send those for re-ranking to produce the final set of recommendations.
Rohan, do you just want to give a one-sentence explanation of what a feature store is?
Oh, yeah. So a feature store is essentially a type of data store that you use to track and version features that will go into your machine learning model. And you want to do this because when you make changes in an offline environment as part of a transformation pipeline, maybe you're spitting features out from another model, you want to make sure that those features are available at inference time, at production time, and you want to make sure that they're the same as when you train your model. Because if they're not, then you're putting all sorts of different data into your model when you're trying to generate real predictions. Does that kind of make sense? Cool. And so obviously the reason why I said you don't want to hit that for all of your candidates is because you need to go and get that data from somewhere. And so that becomes actually a massive problem, as we'll talk about soon. And so just to go over these different steps, the idea of candidate retrieval is to reduce your recommendation set down from potentially billions to a couple of hundred. And this is typically just the idea of taking every single thing that you could possibly recommend and shrinking it down to the small set of items relatively that you probably want to recommend to people. And the idea here is to use a really lightweight model that doesn't use too many features. So you can do this really quickly because you want to save time for the subsequent steps that are execution heavy, kind of, you don't really have a way around that is probably the best way to put that. So you want to save time here where you can. And so this is kind of like what a candidate retrieval model might look like using that two-tower system, where we train our two models in our tower. And then because we have embeddings in the same space, we can build an approximate nearest neighbor lookup. And so the idea here is offline, we take our entire corpus and we put it through our item model, which puts them in an embedding space. We then turn that embedding space into a nearest neighbor lookup, and we can put that into some sort of production system that's really, really fast to query. Then at query time, all we need to do is take our simple features that went into our model, convert those into an embedding with our lightweight model, and then perform the nearest neighbor lookup. And so this seems complicated, but you can actually do this really, really quickly. And there's lots of packages out there from pretty much every major tech company. Google has one, Facebook has one, Amazon doesn't have one, Spotify has one. There's lots that make this really easy. And so this is one model you might train. But one thing that we kind of forget about a lot of the time is that candidate retrieval is the step where we can take into account diversity. And diversity is important because while it's all good to say, I'm going to suggest the best recommendations for this person, I'll retrieve them, I'll score them, I'll give them back to them. In reality, this isn't going to happen. It turns out recommendation systems are hard, and it's very difficult to get a model to learn about what's trending, what's new, what's seasonal, what this person might like, specifically related to their preferences. That's hard enough. But then you have other stuff, right? You have potentially items that you've been paid or you have some business interest in promoting that you want to make sure gets in front of people. But your model has no idea about that. It can't guarantee that, right? You might have additional items that you might want to recommend to users that you think will increase the chances of them exploring. Again, something that when you think about it from a goals perspective, it's not something a model would learn to suggest because it's not going to result necessarily in the outcome you want, but it's going to give you some other outcome, right? And so the idea behind candidate retrieval then is, let's build a model or build a system to do all of these different things. And this will produce a really large pool of candidates that I can use in my subsequent systems. And this will make sure that at least I have them there. They're not just getting lost in a model. Cool. So the next step is scoring. And scoring is where we take those candidates. Let's say we've gone from 1 billion down to 1,000. And we really make the predictions as to how likely we think someone will like them if we recommend them. And so there's a little GIF here from a blog post from Instagram where they say they go from 1 billion items to 500 items to 25 items. And this is how they pick what comes up on your little feed. When you pick, I can't remember what tab of Instagram it is, but the one with the little grid. And so the idea behind this is to be able to take all those different candidate sources, mix them together in the way that you might want, and then produce the best possible set. And to do this, obviously, if we could just predict the best possible things at the start, we would have done that, but we can't, and that's why we used a light model. At this step, we'll have a bigger model that uses more layers and more features. And this is typically where we start to hit an issue around feature hydration, which is depending on what these features are, you need to get them from somewhere. And this is an easy statement to say, but in reality, these features are typically things like, if we use YouTube, for example, might be for the 100 videos that you've got in your candidate pool, for each video has the person subscribed to the person who made this video. How many hours of watch time do they have to that person? Has this person clicked on this video before? Has this person clicked on the videos like this before? And so on and so forth. You can see how this starts to get really potentially very, very messy. And so assuming we have that, that's great. We train our ranking model, which predicts some sort of score, typically using some sort of binary classification or regression, whether you're predicting some sort of propensity as to whether someone will click or interact versus something like a score. And finally, I've got this point here around target weighting. And that's the idea of intent. And so you can kind of predict scores based on intent, where if you have a situation where someone is very, very likely to click on something, and if they don't, that's a bad sign. You might have a score for that be very, very high. Whereas if you have something that is shown to someone and they're not that likely to click on it, even though you've recommended to them, you're going to want to score that lower, just naturally, right? If you stick an ad up in front of someone and they don't click it, if you recommended that to someone, that's a bad sign. Whereas if you've got, a YouTube feed of 50 videos and you recommend 50 and they don't click on one of them, that's not necessarily as bad of a sign, right? They're not going to click on all 50 videos. Cool. And so finally, we have this step called re-ranking. And re-ranking is, as I've put down the bottom, potentially the secret sauce, because it's where you take your recommendations, which are ordered by their relevance, and we kind of order them in a very specific way that we choose based on some business rules. And so the example that I've got here, and using this picture from Canva, and the most common one for us is what we call the free premium ratio. And so this is something that has nothing to do with the content, but it's a business rule that you might have. Because at Canva, if we show no paid content to anyone, no one will subscribe for a premium account, because why would you, right? Like they don't have any premium content. So we have this notion of a free pro ratio, which says, okay, certain users get certain ratios depending on how likely we think they're going to upgrade. And so we do this in different segments, and taking this to the extreme, you might think of it as something like, for a student, we know they have no money and they're not going to sign up. Don't bother showing them all the paid content. Whereas if you're already a paying content, let's max out, my paid ratio. And so this is something that you kind of do by assembling a set of slots and taking all that stuff from your previous ranking steps and inserting it in. And this can go as far as you want. So you might have creator or contributor ratios. You might want to enforce different types of ethnicity across certain domains. You might have a ratio around certain promotions. And yeah, this is kind of how companies make sure that what you see doesn't kind of devolve into just seeing the same thing over and over again, making sure that even though you really love PewDiePie, PewDiePie is not the only person that you ever see on your feed, even though statistically, PewDiePie is the most likely person for you to click on. And so that's the re-ranking step. And I didn't include it at the start, but really what you can start doing is start having models that predict these ratios based on people to make sure that they get, the ideal experience personalized to them, not just in regards to the content, but also the experience.
Rohan, a couple of questions.
Mm-hmm.
I'm imagining there might even be things like color ratios and stuff like that. In practice, you know, if you're looking at the uplift of this multi-stage system, is this often where you get the biggest uplift?
Yes. So we have this free premium ratio. We have whole projects around making sure that that's working and controllable. It has a huge correlation between the people who sign up, the amount of revenue you make, all that kind of stuff. Just because once you get to a certain scale, just statistically, you know, showing 10% more paid content means X% more people are just going to sign up, for example.
When it comes to choosing a loss function, maybe not in a candidate retrieval, but when you're starting to refine and rebrand, you know, you can obviously use loss functions to promote novelty within the model, or you can do it manually here.
Yeah.
Is there usually a process, like your first version, you do it manually, but then you try and learn that the model?
Yeah, so trying to learn this is very, very difficult because you essentially need to simulate the business outcome of putting this in front of a user. And so for that reason, like at Canva, we do a lot of A/B testing to do that. We have a framework, which I'll talk about, which lets you run very fine-grained A/B tests. But there are also reinforcement learning algorithms that I've seen around trying to make this stuff easier because that simulation type environment is more suited to that type of thing. Yeah, cool. All right. So moving on. Now that we know about these systems, I'll talk a little bit now about how we're doing this all at Canva. And I'll preface by saying we are not doing every single thing that I've shown here. This is all a lot of work, as you'll see, but we've made progress in all these areas at different levels to facilitate some of the things that I'm about to show. And so the first type of recommendation that we have is something called the item-to-item recommendation. And so in a template context, you can see here that this is about saying I have an item and I have other items I want to recommend. And there are lots of different ways about doing this, right? You can do this by checking what are other items that people use, what are other items that look the same, what are items that are statistically most likely for someone to convert to a paid user. And for this type of model, typically you can get away with just candidate retrieval because these types of models are relatively basic and they don't take into account a lot of user context. In saying that, you definitely can take that to that extent. So for example, for this model here, we're actually doing candidate retrieval using OpenAI's Clip. So we're doing a whole bunch of stuff around that. And then we also have started doing some stuff around the re-ranking to denote these ratios. We also have this for something like when you're designing. So you can see here that we have 3 separate types. We call this magic recommendations of recommendations. One that is extremely stylistically related, whereas this one here is less stylistically related, but is obviously related in terms of themes. And this one here is somewhere in the middle. And so we, again, use similar types of models for this stuff. And this is the most basic type of recommendation.
To do that, have you trained those on different elements?
Yes. Yeah. So we have, this was kind of one of our first models, and there is a natural progression from this, which I'm about to show, that kind of pushes this to the extreme in the context of Canva. It's quite cool. So the next one is a personalized mixed masonry. And this is the thing that we're all kind of familiar with. And this is where all of those components really need to be working together to give someone a good experience. And so you can see here, like my recommendations get all messed up because I just click on things to test. But you can see here that the model has obviously figured out that I'm into some sort of sales. It's obviously figured out that I have some certain specific color schemes that I like. But it's also tried to insert, content related to Australia because it knows I live in Australia, even though this content doesn't match any of this other stuff. And so this project here around personalized mixed masonry is really what is driving a lot of the work at Canva around recommendations, because of kind of the complexity that actually goes into making something like this, that, you look at it and it looks nice, but when you get one and it looks bad, it's really, really noticeable. And so the third way that we're using recommendations in a big way is something that we call design context recommendations or contextual recommendations. This is the idea of recommending things based on what the people are doing. And so you can see here that we have a blank canvas and some things that are recommended to me. But as soon as I start adding things, we start making recommendations, right? We start changing things up because we know if this is what you're designing, this is probably what you want to put into your recommendation. And this comes back to the whole idea of, if we have a giant library, we don't really want lots of people to have to go trawling through the library to find the perfect thing for their design. We'd rather just make it available to them. And this becomes really apparent when we go to the next slide, which is my little cover art that I designed, where you can see that the model has now said like, oh, okay, this person is making some sort of vaporwave thing. Let me start recommending them vaporwave stuff. And I've cherry picked examples here because this obviously gets very confusing and messy when people start doing all kinds of different stuff. But this is one of the really interesting problem spaces where we're finding using all these different recommendation system tools is really a must to figure out problems like this. And so, yeah, I thought for the last bit here, I thought talk a little bit about kind of our practices and how we're actually doing this work at Canva. Sorry.
Just go back there. Your contextual recommendations, like the good buzzword that being session based. Is that right?
So we call it, we'd say more contextual, but yeah.
But your contextual recommendations are session based, yes?
Yeah. Yeah. And I will just preface, we don't like read, just in case it's not clear, we're not reading all the stuff you write in your designs and stuff. It's all about how it kind of looks. So we're not gonna.
So in other words, it's just I would something like that, session based.
Yeah.
Yes.
Yeah. Well, so
every time I come on, I'm not going to have my recommendations skewed by the last project that I was working.
No, exactly. That is true, but there is also a certain level, and this is something that we're starting to play around with, of what we call like global personalization, which is if you can learn certain global traits about a person, you can also start to carry those throughout their full experience. So for example, I might learn, you hate the color red.
Or you might always use a brand's colors.
Yeah, you might always use something, so we can start to use that throughout. Cool.
For scholars, is that you get information from tags, or
we use a combination of tags and kind of IDs and embeddings. And we're just now starting to get into using visual models to ingest the visual content of items as well.
So the idea would then be, as you place different things there, you get a dense representation from a computer vision model into the lookup.
Yes, yeah, there's a little bit more stuff than a lookup to process it, but yeah, we're processing all of this into stuff and then sending it through the system to make recommendations. Yep. Oh, sorry. All right. Yep. I'll do that. Sorry. Yep. Cool. So
before you move on, one quick question out of curiosity. Yeah, would the computer vision model like scan what you're creating as a whole, or are you saying it would look at the individual items that you put in?
Yeah. So the question was, would we scan the whole image as a whole, or would we scan individual items when using a computer vision model? So mostly for personal information reasons, we would never put the whole thing through because we just don't want to be transporting because you don't really know what people are writing or anything like that. So we do them all individually, and we've kind of got a mechanism now to keep track of the position of everything in the page. So we know what items are where and how they're orientated, how big the text is, what fonts used, all that kind of stuff. So you can essentially think of that as being represented as some giant blob of JSON, I guess, that you can then start extracting information out to start doing stuff like this. Yeah. Cool. And so with that all in mind, I thought I'd talk a little bit around how we do this stuff. And so the first point here is kind of the most important, and it's maybe one of the reasons why you really only see big companies doing this stuff. And that's because event capture infrastructure is absolutely vital. If you don't have good event capture infrastructure, and obviously this is becoming democratized through things like Segment, you can't know what your users are doing. You won't know what they're clicking on, what did they see, and then not click on, what did they do on your platform? And that level of, like, the granularity of interactions that you have are really what drive a lot of these models. And so we have a system, it's been renamed to Analytics Event Service, Product Analytics Platform. It used to be called Canvalytics, but apparently it's not that's a bit too trendy. So we got to change it. And so, yeah, we have a system there that what that does is pretty much everything you do in Canva triggers events that go through to our data infrastructure. So once that backfills through our data lake followed by the data warehouse, the machine learning engineers have access to all this stuff. And that's really the most important thing to have if you want to be building recommendations at scale. The next thing that I've got here is about offloading data management, pre-processing, and processing. And so we use Snowflake as our warehouse. And the reason that this is really important is because these data sets get really big. I think a 7-day data set of click interactions turns into anywhere between 300 and 500 million clicks for us at Canva. And we're not really that big in comparison to some other companies. And so when you're building models, you don't want to be playing around with this stuff in something like pandas because it's just not feasible. And so what we do is we really offload a lot, as much pre-processing and data munging to other systems. And this makes sure that when you need to process the data for a model, you can use some highly optimized framework like the TF TensorFlow data or something like that to be able to ingest and just run your models without needing to worry about moving stuff around.
When it comes to using rich media images, how do you then do that? When it's not relational or something else?
Yeah, so this is something that we're working on at the moment, but it becomes a matter of essentially building dedicated infrastructure to map relational IDs to like the blob store or something like that. Because yeah, this is actually a problem that we're facing now because we don't have a great way of importing our entire media library into a training environment. So we do a couple of things, but yeah, there really is no easy way to do it, I don't think. A lot of people use stuff like Apache Beam and things like that because that kind of lets you work in a little bit less structured environment where you can use the tools you're used to, but still get advantage of that compute. And if you don't want to use that, you can start getting into Hadoop and things like that as well, which is still actually reasonably popular, even if people don't like that.
Hadoop specifically or Spark?
Spark, yeah, Spark. Cool. So the next point that I have here around training, and this is something that we've really been, not necessarily me, but people at Canva, and something that I've really got on board with, is prototyping in notebooks and moving to a repository as soon as possible. And so this is really important, we found, for two reasons, testing and code review. And these are things that typically, data scientists and machine learning engineers don't like to hear. But it turns out when you have heaps and heaps of features and data coming from all kinds of places, doing all this stuff in your notebook where no one can see it is kind of a recipe for disaster a lot of the time, because as you've seen here, the real trick with all this stuff is moving all this stuff into your system. And the earlier you start doing that and getting other people's input on how to optimize your code, how to make sure things are streamlined, how to make sure you just don't have bugs, the easier it is to actually start deploying these systems. And I know for myself, it was a really difficult transition for me to be able to move from a notebook environment to something like writing unit tests on my Kubernetes, my Dockerized code, and then deploying that to a training cluster where I can't, poke and feel at things. But the reality is, for us, this has actually been really, really beneficial. And the third point here is what I kind of just mentioned, which was moving your training away from you and onto a training cluster. And again, this is hard to grasp because you can't touch and poke and prod at your model in your notebook. But being able to, well, one, this kind of forces you to write code that is better and write code that is more similar to production. And two, it actually makes managing things like experimentation and logging a lot easier because you're no longer just running code over and over and over again. You can define a set of jobs with parameters, send them all off, and then you see what comes out. And we use a tool called Mlflow, which is an open source tool for tracking experiments. All our containers just log up to that central database, which goes to the dashboard. And it's very similar to something like TensorBoard, but all the actual grunt work under the hood is happening somewhere else.
Do you use Mlflow for your experimentation as as well, or do you just use it as a logging platform?
We use it for both at the moment. There's a bit of investigation into expanding into a couple other tools just because it can be a bit limiting. But it's just what we started with when we were spinning up this platform. But yeah, we don't use it to like determine the experiments or anything like that. Just logging, really. Cool. And so the next step is evaluating, and evaluating is really hard, particularly in this space. And I'll talk about it at the end with that bolded statement. But as I said, we use Mlflow, which we use for tracking and monitoring experiments. And we put quite a bit of effort into making sure that we're using proper, useful metrics. It turns out these aren't that useful in reality for a number of reasons. But it's important that you define this stuff before you even start, because it's really easy in this space in particular to kind of put yourself into a bit of a confirmation bias headspace. And that again comes down mostly to this reason at the bottom, which is what makes good recommendation. And you might discover it's very easy to kind of convince yourself that almost anything is a good recommendation depending on what you're looking at and how you want to perceive it. So the other thing that we do is reporting. So specifically for us, we work with a lot of visual content, and that means that we generate these reports that let us look at what's coming out of the models and query the models that are going into production before they go out. Obviously, you can check all of this in production, but it becomes much harder to simulate the environments that will produce outputs, particularly when you get into personalization. And that's just because, your state of your query is not just, one item. It's a user who's interacted with certain things certain times ago on a platform, in a certain locale. And for that reason, we find being able to, do this poking and prodding and testing of your model before it goes to production is super, super important, despite how, silly that kind of sounds. And the next two are about testing, really. So we do integration and performance testing quite thoroughly these days. And that's because we found once you get into this environment where you're not running your models on your machine, as I said, you can't poke and prod. And so what this means is, sorry, totally just lost my train of thought. When you can't poke and prod, it's hard to know what's going on. And so when it's hard to know what's going on, stuff will break. And it turns out that it's not a very efficient dev loop to be writing code, pushing it to a cluster through the CI system, having it fail, fixing the bug, pushing it to CI. And this loop becomes very, very tedious, as anyone who's done it will find. And so that's why we find integration and performance testing so important on the code that you are training on and the code that you are going to be serving. Because testing in production or staging or even dev or on your cluster is just a bad idea. And this should really extend even to the level of unit testing, both to help you develop faster and also just so your process is as streamlined as possible. And so I've written here that we mimic production as thoroughly as possible. And what that means is, like, essentially, if you have code that is going to be running in production as a model, you should be testing that code, that Docker container or that Docker image. It's not take your model, train it, and then run a performance test. It's take the model, put it in the production environment and test it in that environment. Because as soon as you start changing things, that's when, you get into the whole, oh, but it worked on my machine thing that we all know.
For your integration test, what's the mix of that of just getting it to run and accept inputs versus actually testing the outputs, maybe, not necessarily click, but basically going, is this a sensible prediction or is it the same as what I got in training?
Yeah, no, so that's a tough thing to do. And so we've tried it a little bit, and what we found is it can be helpful to really define like real bad failure cases, which you can use things like the embedding spaces to say, this is completely wrong, or this is, not producing the same output 10 times or something like that. For us, we found it's mostly around making sure that when you query, you're getting back something reasonable. And so I'll say here, I would personally differentiate an integration test with a quality test, because the quality part becomes really, really tricky. And the reality is a lot of large tech companies really offload a lot of this to human evaluators through something like Mechanical Turk or something like that. Because as you said, it becomes a question of like, how do you know if what you got out was even good? Yeah. And the last one here is live A/B testing. So everything we do at Canva goes through an A/B test on some segment that we define before it hits production. And that's just because even if your metrics are great in the offline test, you don't really know what's going to happen when this hits real users. And so this becomes even more of a thing when you start thinking of the concept of segments. And for us at Canva, a really big one of those is lots of different locales. And it's very easy to think, my metrics are great, everything's looking good, but in France, the recommendations are terrible. But that didn't affect your metrics because, the French data makes up a very small percentage of your validation data set. And so things like this are why you need to run extended A/B testing on real users to really understand if what you're doing is making an impact.
How do you manage the promotion of models? Do you have it automatically start shifting? Like as you collect more data, it starts to shift progressively to the newest model, or do you sort of have a manual checkpoint? And if it's better, then you push that to all users?
So for us, the way we currently handle a lot of models means we retrain each day because of the way the new content is handled. And so we have like kind of minimum thresholds to make sure that it's not regressing. But aside from that, we kind of just let a lot of things go. But typically, like the state that we would want to move towards is essentially having these segment level quality tests, and then making sure that if you don't have regressions on those, then you're fine. The reality is that we shouldn't really be training and testing retraining and redeploying every day. But until we get to a position where with our setup, we can do that. That's what we're kind of forced to do. And so what tends to happen in most larger companies, from what I've learned, is you really want to train as little as possible. Like you don't want to retrain your model and redeploy unless either you're making some serious gain and like there's a real reason to do it, or something's gone wrong. There typically isn't a good reason to just retrain and redeploy a model just because. Yeah. Cool. And then, this last point here, kind of a kicker. At the end of the day, what makes a good recommendation? And this is a question that kind of plagues everyone in this space because it's true. It's really, really hard to say if what you recommended to someone was good because they liked it, because it was the first thing on their page, because as we've observed on Canva, they're just clicking on everything. There's a whole host of reasons as to why someone might click on something, and there's a whole host of reasons as to why someone might not click on something. As I said before, if you put 50 things on someone's page, you can't expect them to click on them all, even if they were the perfect recommendations, right? And so we're starting up a bunch of research on this, but it turns out that this is a really, really tough question to answer. And so I might start speeding things up a little bit, but in terms of deployment, we use AWS SageMaker because at the moment it provides us with a really flexible piece of infrastructure while we build out our own stuff. And it gives us all this kind of free stuff, right? Auto scaling, load balancing, monitoring, rollbacks, blue-green deployments, all that kind of stuff. This is all the stuff that if you don't have, SageMaker to use, that's a massive task for your infrastructure team and your data engineers to build out. The next step in our system to deploy these things is to kind of use the CI. Obviously, we have these Argo scheduled trained workflows that we run our tests. We don't even push containers into the repository unless they pass all the tests, because you just don't want something that could potentially be bad getting into or anywhere near your environment that might be pulled up by the deployment process. This is again similar to what I talked about before, but the containers, being hermetic and injecting your model dependencies straight into container means that you can test and debug your live production environment when you're not live. And that makes things a heck of a lot easier when you start getting all sorts of weird queries coming into your models. especially when you start to have the systems, communicating with each other, where you have the outputs of one model going into the outputs of another. If you're trying to figure out if the issues are because of your system or because of your model or because of the interface between the two, you want to make sure that you can test each part as independently as possible. And the final point here is to tie model servers to input and output specifications and tie these to your backend that it's communicating. And this is just so that when you are communicating with your recommenders, you know exactly what model you're talking to, and it's the model that you have trained and you intend to talk to, and you know exactly what features it expects, so you can give those to them. It's very easy to make a small change and deploy a model and not realize and have two things that shouldn't be talking to each other all of a sudden start talking to each other. And things not really become apparent until, a little bit down the line, when all of a sudden you realize the model from 2 weeks ago has accidentally ended up in prod, but it's still running because, the inputs were the same.
Deploying this system, there's multiple models in this pipeline. Are you typically working on them separately and deploying them separately, or are you trying to tie it all together and look at end-to-end metrics?
So at the moment, we do them all independently, but we are starting to look into doing the latter because especially once you start to have multiple candidate generators mixed with the ranker, mixed with the re-ranker, it's not really a suitable assumption to make that what you're doing there is valid. Yeah. And so you can do that by doing your deployment just as a collection of pods or something, as opposed to just individual stuff. How much time we got? How much time do we have? Sorry. 15 minutes. Yeah, cool. No worries. And so I thought I'd put a little diagram here as to what all of this looks like in the end. And so this is kind of like what happens once we have all of our servers, all our infrastructure, and we want to talk to the model. Putting this together, we end up with something like this, where we have some user who requires recommendations. These recommendations can come from a couple of different places, right? They can either come from some real basic KV store. This is like a really, really simple candidate generator that might be looking up the top items in your country, for example.
What's a KV store?
Key value. So something like DynamoDB or something like that, or Redis or anything like that. DynamoDB is not actually a key value store, sorry. And then we have our feature store. And so if we're making real-time recommendations, we need to go and hit the feature store. And something that we've kind of started doing is using this thing called the nearline cache. And the idea behind this is if you have to generate recommendations every time someone makes a request, that becomes quite challenging on your latency budgets. If you need to make a call to a model every single time someone loads a page. So something that we've started doing is taking advantage of event streaming infrastructure, where we watch for when people do things that would change the inputs to a model, if that makes sense. And so when we detect that someone's clicked on something new, a worker picks out that change, and then it goes and hits the model with the new set of inputs and then puts those in a cache. And so that way, your real-time model, most of the time, doesn't actually need to be real-time. And this is a pretty handy strategy we found, because when it goes to make the real-time recommendation, it will find, oh, I've already got a recommendation for the state of the user, or the latest state of the user.
Do you have a way of automating that? So if you add a new feature, there's already basically a list, so that when you push the model, that query gets updated to make sure it's checking for the additional feature?
So at the moment, we manually have a whitelist, I guess, of different events that it's watching for, just because we do some hacky stuff of pretending that certain events are certain other events and stuff like that. But yeah, things get a bit messy when you start thinking about backfilling and things like that, when you need to make recommendations for users who haven't done something new, essentially. Yeah. And so this is all connected then to our containerized endpoint. In this case, we're using SageMaker and a TensorFlow model, for example, which has been put there from our whole offline training loop. And so this offline model could also be used for something like batch inference, where it could be, you don't need to do real-time information, real-time predictions. It might put stuff into your warehouse, which then, subsequently will feed into your KV store. So at the moment, we don't actually use dedicated feature store. We have a in-house built feature store that's built on top of DynamoDB. Yeah. And so that's kind of what it all can potentially look like. And we're starting to see now more and more why we talk about recommendation systems and not recommendation models. There's two more things I wanted to talk about, which I might just go through quickly because I think I spent a bit too much time at the start. But the first one is monitoring. And so the way I phrase this here is your deploy model should not be treated like a special component. 2021 machine learning is still new. But in an environment like this, at this scale, it doesn't fly to be able to say like, my model needs to be handled like this. So we need to make sure it has these resources, or if it goes wrong, you can't really say, oh, the machine learning model went wrong. Once your model becomes part of your backend infrastructure, you need to treat it like part of your backend infrastructure. And this means monitoring all this stuff to know if something is wrong, if something has gone down, if an on-call engineer needs to be called, for example. And so do things like, latencies, HTTP code rates, resource usages. This one is really important when you roll out new models, because a lot of the time you'll roll out a new model with a new feature and you won't realize that it's going to blow up the RAM on your server when it starts getting, tons and tons of requests. Down to stuff like, how many times is it getting hit? How many times is it responding? All that kind of stuff. And ideally, you want to also be monitoring downstream feature use. If you're producing recommendations, you want to make sure that, okay, sure, it's producing, responding to the requests, the memory hasn't blown up. But I also want to make sure that on the front end that my clicks are coming through. Because if not, then something, again, has gone wrong in my pipeline. And this, again, comes down to the idea of having really good event capture infrastructure. And then obviously the top level one here is A/B testing, and that's making sure that 2 weeks into your rollout that half your user base hasn't quit or something like that. Making sure that anything that you roll up is having positive impact on the general engagement or your core business metrics. And if it's not, that you can justify the trade-offs that's happening, right? So for us at Canva, that might be being willing to lose a number of subscriptions in order to get more paying users, for example. And monitoring is really how you figure out, at the end of the day, is everything that I've been doing actually working and going well? And so at the end of the day, this all kind of comes down to three things. And one of these is new that I haven't talked about, and that's performance, quality, and fairness. And the point that some of you guys might have learned at this point is that while online inference for real-time recommendations is very cool, there's all this stuff going on, it is extremely expensive. And there's, as you've seen, a huge amount of work, a lot of which is heavy engineering and data engineering work to get even basic systems like this off the ground in a scalable system. And once you get those off the ground, there's all sorts of problems that you didn't expect. And this is particularly pertinent when you start talking about personalization, because you quickly realize that there is no way that you could have modeled or monitored or prepared for some of the very odd combinations of things that people will start doing in your product. And so examples of this for us are things like a user who uses English templates and all the time, they write all their designs in English, and then all of a sudden they change their language to Latvia and they start using Latvian templates for a day. And so now what do you do? Has this person become Latvian? Is someone who is Latvian on their account? Do I keep recommending them English things? Do I start recommending them Latvian things? What happens when they switch back? All these kinds of weird things that you don't think about start to happen when you start letting everything users do influence what they see. And it's really, really easy for this to turn into some real strange feedback loops, which often don't really become apparent until a little bit too late. And the last point that I just wanted to highlight here is fairness and diversity. And this again comes down to the idea and is kind of negatively perpetuated by feedback loops. But it's the idea that a lot of the time, what you think is the best recommendation or what your model learns to be the best recommendation might not just be the best thing to show to people. And something that we really try and focus on at Canva is making sure that we are fair with how we show contributors from different languages to people around the world. It's very easy if you have a very large English speaking user base to only show everyone English templates. but you've just hung out all the people who are working on your platform, designing in every other language out to dry, just because your algorithm decided that people probably won't like them and they'll like the other templates more. And you can do a whole talk on this. And I think I saw there was a reading group on some of the ethics around AI. But I'm sure everyone here has, you read the articles, seen the news around when recommendations go haywire. And if you don't kind of plan for this, and I'm not going to claim that we planned for all of this from the start, it's very easy to find yourself in a really bad place with not a lot of recourse of how to fix these things because, well, the model has learned what it's learned. And that's it. Thank you for listening. I hope everyone learned something new today because obviously this is an interesting new space for most people. And just last thing, Canva is hiring. Quick plug. So as I said, when I joined Canva, my team was at 12 and we're now at 45. I think the company has gone from 650 to over 2,000. But machine learning, backend engineering, all kinds of engineering, we're really looking for people. One of the points I wanted to point out here is that the company is really, really good about flexible and remote work. As I said, I've been working here for a year and a half now, no issues. I go to Sydney every now and then, but not now otherwise. But we have all kinds of stuff, all kinds of problems in search and recommendations, design automation, which is about making it easier for people who aren't experienced in graphical design to make really, really cool looking stuff. Obviously, we have a video editor, an audio editor, which has all kinds of tools in there. And then we get into kind of other stuff like performance marketing and targeted advertising, as well as obviously our ML ops platforms. And so, yeah, if anyone is interested in this space, we have a lot of really cool problems and we'd be happy to have a chat, or otherwise feel free to head online and scope it out. Cool. Thank you.
Thanks. So yeah, thank you, Rohan. That was awesome. Probably one of the most interesting talks I've been to here at Queensland AI. Yeah, we don't often see a lot of the engineering challenges that goes into these systems. And I think you'd probably agree that recommendation systems are one of the, if not the hardest system to actually put into production. I would agree with that. Yeah. Cool. So thank you so much, Rohan. Again, Canva is actually an awesome company. It's an Australian company. It's still private, and I believe no plans to list for a while because you guys are really focused on making an amazing product. Really great success story. So yeah, check out, I know you guys are recruiting a fair bit at the moment. But as far as other things happening locally, Rohan mentioned there's a couple reading groups coming up. So there is one coming up on AI ethics. That is actually run by Rachel Thomas, Jeremy Howard's wife, co-founder of Fast AI, and has done a lot of great work, one of the main people in the space of AI ethics. So definitely check that out, although it may already be booked out, but keep an eye out for the next one. She'll be running those probably every month. And then we also have an AI paper reading group that Sean McMahon is running, which I believe is next week. So there's a few extra groups happening, a bit closer knit, a bit more specific, and particularly for those who are more technical and working in the space, you should get a lot out of that. So other than that, oh, and also Rachel Thomas will be talking at next month's meetup as well. And hopefully we can get that space back. We'll get the booking sorted again. But yeah, thanks everyone for coming down. Thank you for managing with the sound, which we didn't expect. But looking forward to seeing you at one of those groups or next month. Thanks so much. Thanks again, Rohan.